Okay, so I think it probably at this point you realize that we need to do partial fractions on this. So let me put the equal sign down. I can put the sum, n equals 1 to infinity. And I'm looking at this thing, I'm going to say, I got to get partial fractions. I got to factor the denominators. Now I'm going to save that work for you, but I want to point out the work is over here. And the work we get is this thing over here. So I notice there's a 1/10 of that. So what I want to do is I want to factor it out. 1/10, 1, 1. I factored it out. And what are you left off with? 2n minus 5, 2n plus 5. And again, what I'm claiming over here, this has to be done. What has to be done, you're looking to do partial fractions. So again, if you're struggling with this and can't do that, all I can say is come see me and we'll work on it together, all right? But all the work is down there, exactly as I would do it in a Math 119 class, and I'd get this over here. So my understanding about this over here is that I got to get a partial sum. All right, I'm going to write that down for you. I'm looking for Sn. And Sn is going to be 1/10 times the sum, times the sum, n equals 1, that's little n, up to big N of this business over here. It's going to be a little more complicated than the other ones, but I do want to write it down for you. What's it going to be? 1/10. Let's write it down. I'm starting at 1. So what do you get? You get 1. 2 minus 5 is minus 3. I get 1, 7. There's a reason for writing things down, is so you can see a pattern to it. 1. This has something to do with the thing going up by 2. So minus 3 up by 2 would be minus 1. If you want to plug in 2 there, you get 4. 4 minus 5 is going to be minus 1. Minus. This is also going up by 2. 7 up by 2 would be 9. Let me keep going. Plus 1. I'm going up by 2 on the bottom, so it's 1. Minus up by 2, 11. Plus, I'm just looking for a pattern, by the way. 1/3. Minus, I'm going up by 2, 11, 13. Plus 1/5. Minus 1/15. Plus 1/7. Minus 1/17. Let me make sure you know what I did over here. N equals 1, I'd get minus 3. Whoops, sorry about that. And I get 7 here. I'm going up by 2. Let me do the 7 first. Up by 2, 9. Up by 2, 11. Up by 2, 13. Up by 2, 15. Up by 2, 17. If you're at minus 3, up by 2, minus 1. Up by 2, 1. Up by 2, 3. Up by 2, 5. Up by 2, 7. Let me go backwards. I'm trying to get rid of all the red highlighting. So instead of continue to write them down, I can, but I think I see something now. And what do I see? I see that this guy here is going to cancel this guy over here. And this guy here would cancel somebody over here, so forth and so on. Like after 1/7, you get 1/9, then 1/11, 1/13, 1/15, 1/17. I want to go to the end, though. All right, I know the beginning of it, but I want to go to the end. So my claim over here is this goes on, but I want to go to the end. And what's the end going to be? I got to be careful here. It's going to be 1, 2, big N, minus 5. Whoops, I went too quick, though. I shouldn't have done that. Minus 1 over 2, big N, plus 5. Now, notice how when in the forward direction it's adding 2. Now I'm going to be taking away 2. All right, let me do that. And I know I got subtractions over here every single time. So it's going to be 1 over 2n. I'm going back by 2 now, right? So minus 7. back by 2, back by 2, back by 2, right? Let me just go one more. And back by 2 minus 15, right? All right, let's do the other one. Back by 2. 2n plus 3. 2n plus 1. 2n minus 1. 2n minus 3. 2n minus 5. You know what? I think I see it there too. And what am I seeing? This and this would cancel. I hope you realize that this is going to cancel something over there. This cancels something, and they go all backwards, all right? Then someone says, I wonder what you're left with. Let's write it down. Certainly have 1/10. I'm going to concentrate on this portion now. That's the beginning portion. And I'm looking at that. And what would you get there? I mean, a lot of things disappear in that too. Like the thirds disappear, the ones disappear, and you're left with 1/5. That's not so bad. In the end, what are you left with though? You're left with this nightmare. And no, I can't do anything about that. It's there. Let me write it down for you. Minus 1 over 2n minus 3 minus 1 over 2n minus 1 minus 1 over 2n minus, plus 1, going up by 2, minus 1 over 2n plus 3 minus 1 over 2n plus 5. All right, someone says, is that Sn? I think so. You know, mistakes happen. So what do I want to do? Again, we talked about the partial fractions. I just want to see if I got the same Sn. All right, this is the Sn over here. That's the work on it. Make sure you know what work means. You can't say, look at that and say, oh, that's right. You got to do the work. What did I say, 1/5? Yeah, then, 2n minus 3, 2n minus 1, 2n plus 1, blah, 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 up to that. We did okay. What am I going to do now? I want to do S infinity, all right? So how do I do that? Limit as the big N goes towards infinity of Sn. I'll do that in a moment. What's that going to equal? The sum, N equals, let me go back to the original sum, by the way, 1 to infinity. It's 1 over 4n squared minus 25. And what's that going to equal? I can certainly look at that limit, by the way, and do it. And why is that? I'm looking at this. Important thing to look at. And what do I know about that? It's a very simple limit as n goes to infinity, the big N. What do I get? 1/10 times 1/5, which is 1 over 50. And that's the infinite sum. Thank you.